In this video, I'm going to review how to draw Lewis dot diagrams for individual atoms. The difference between the Lewis dot diagrams and the Bohr models is that with the Lewis dot diagrams, we're only going to include the valence electrons. We're getting rid of all the other electrons, and we're also not going to bother writing in the number of protons or neutrons. So if we look at beryllium as our example, Be, first we need to find it on the periodic table. It's right there. And we see that it's in group number 2, and that tells us it has 2 valence electrons. And we're going to draw one there and one there around the symbol. And that's it. We write the electrons on opposite sides just to represent the fact that electrons don't like each other. They repel each other because they have the same charge. If you were asked to draw a Lewis dot diagram for magnesium, well, you can see magnesium is right underneath beryllium. It's also in group number 2, and so as far as the valence electrons are concerned, it's going to look just like beryllium. Right? It does have more electrons than beryllium, but it has the same number of valence electrons. Now let's look at a nonmetal. Let's look at nitrogen. Okay, nitrogen's over here. That's atomic number 7. And you'll remember the pattern that we learned for figuring out how many valence electrons there are. If they're in group number 1, that's 1 valence electron, 2 valence electrons. And then we're going to skip over all of these transitional metals until we get over to here. So boron and those elements in the same group as boron, they all have 3 valence electrons. 4 valence electrons, 5 valence electrons, 6, 7, and 8 valence electrons, except for helium, because helium is so small it doesn't have 8, it only has 2. But it still has a full outer shell. For helium, 2 electrons is a full outer shell. Okay, so back to nitrogen. Nitrogen, based on what we just said, has 5 valence electrons. So I'm going to draw 5 valence electrons, and the way I'm going to draw them is like this. 1, 2, 3, 4, 5. So I spread them out until I've gone around, and then I start to double them up. And the only reason we do it that way is it will be easier later on when we get into drawing molecules to show electrons in pairs. Okay, so nitrogen again has 5 valence electrons. It has 3 unpaired electrons. Right, 1, 2, 3. Those are all unpaired electrons. Unpaired. And it has 1 pair here. Okay, that doesn't matter so much right now, but later on when we get into bonding, that will matter.